So let's have a go. For the equation x squared plus y squared equals 4, describe the shape of the graph. So you have to be able to recognise that this is a circle. State the coordinates of the centre. Well, nothing is being added to or subtracted from x or y before they're being squared, so the centre is the origin, 0, 0. State the radius. Well, this number on the end is the radius squared, so the radius must be 2. Determine the exact value of y when x is 1. Let's have a go. X is 1. 1 squared plus y squared equals 4. So y squared is 4 minus 1, which is 3. And there's two possible values for y. It's plus or minus root 3. Either the positive or the negative will square to give me 3. So there's two possible values for y when x is 1. Let's try. Whoops, I wrote C, that was D. Sorry about that. Let's try E. Exact value of x when y is a half. So x squared plus a half squared equals 4. Well, that means x squared plus, now a half squared is a quarter. X squared is 4 minus a quarter. You might be tempted to go 3 3/4, but that's not actually going to help us. I want to have an improper fraction. 3 times 4 is 12, plus 3 is 15 quarters. And then x, whoops, not squared, x is plus or minus root 15 on 2, the square root of 4. Now 15 is 3 times 5. There's no square factors in there, so I can't simplify that surd anymore. So there's two possible values of x when y is a half. Sketch the graph and label the points of interest. Okay, it's a circle centred at the origin, so my centre is 0, 0, and then it's going to go around here, 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 and here, because its radius is 2. Now drawing this neatly, well, as neatly as I can by hand, doesn't have to be perfect, as long as it looks approximately circular, that'll be fine. We did work out a few extra points. We don't have to label these. X is 1, y is plus or minus root 3, which is about 1.7. X is 1 plus or minus about 1.7, they look right. Y was a half, x was very nearly, oh, this is hard to say, isn't it? Actually, it's very nearly 2 because 3 3/4 is very nearly 4, and that lines up with this. But we don't have to label those because we weren't told that we had to. The points of interest for a circle is really just the origin, and the radius is marked as 2 somehow. But we are about to add a few more points of interest. Determine the coordinates of the points where this intersects y equals 2x, and label those points on the graph. So y equals 2x is a straight line through the origin of gradient 2. So in 1 across, it's going to go 2 up. So that's the graph there of y equals 2x. Actually, I should probably label my original graph, x squared plus y squared equals 4. But what are the coordinates of these 2 points? Notice there's 2 points. If you're having a circle and it's going to intersect, expect 2 points. Of course, if that line was over here, it might just touch as a tangent, and there would be 1 point. Or if the line was, not touching the circle at all, there'd be 0. So let's try and work out these 2 points. What we're going to do is simultaneous equations with this and that. So this is G. X squared plus y squared equals 4. Equation 1. And y equals 2x equation 2. So I'm going to substitute for y, I'm going to put in 2x sub 2 into 1. X squared plus 2x squared equals 4. X squared plus 4x squared, everything inside the brackets gets squared, is 4. 5x squared equals 4. X squared equals 4 on 5. Can you work out what we're going to do next? X is going to be plus or minus 2 on root 5. Now there are some people who say you shouldn't put a square root on the denominator. I'm not one of those people. I do not mind having an irrational denominator. So I'm going to leave it like this for now. X is plus or minus 2 on root 5. But what are the y coordinates? Well, I'm going to have two different ones. If x equals the positive one, 2 on root 5, then y is 2x, so that's 4 on root 5. And if x is negative 2 on root 5, then y must be 2x negative 4 on root 5. Let's see if we can put those points on the graph. So, if x is 2 on root 5, y is 4 on root 5. Mark. 2 on root 5 is getting a little bit ugly for this fat pen. I like wide nib pens, but this is getting a bit hard. 4 on root 5. And this one down here is negative 2 on root 5, negative 4 on root 5. Notice, if this line had gone this way instead, I would have had a negative x and positive y, and a positive x and negative y. Be careful.